All right, gang, Mess 1700, nearing the end of the, let me find an ink pen that works. Okay, nearing the end of the course, which is always good news for everybody involved, uh, you and me. Uh, I'm going to get into a little bit more advanced mathematics of finance problems. So what you can expect coming up in the next 3 to 4 videos is something like this. There's going to be more advanced problems part one. There's going to be probably in the next video is going to be more advanced problems part two. Duh. And then I'm going to get into illustrating how we can work some of these problems using spreadsheet, just basic spreadsheet application. There's going to be some of you out there that know a lot more about spreadsheets than me. I know how to manipulate spreadsheets primarily for things like this and in the most basic sense, and then of course statistics. But so anyway, let's get going. Let's get this behind us. So, question number one: the Smiths intend to purchase a home for $175,000. They intend to amortize their loan with equal monthly payments over 15 years. Their bank has offered a 4.95% annual interest rate. How much interest will they pay in the first 5 years? So, I'm going to let me get things centered here. All right, there we go. I'm going to use the calculator, which oddly I don't have up for some reason. So you can grab your calculator, and first thing we need to do is we need to get this information in the calculator and find out what the monthly payments will be. So, guys, y'all should know by now that we go to Finance and TVM Solver. So it looks like they're financing over 15 years. The advantage to financing over a shorter period. The typical financing times are 15, 20, 25, and 30 years. Obviously, the advantage of 15 over 20, 25, or 30 is you pay less interest, but the disadvantage is your payments are higher. So if you're very disciplined, and typically, usually you can get a lower interest rate too if you go 15 versus 20 or 25. So where are we at here? Present value is 175,000. Payment we don't know yet. We'll come back and get it. We want our future value to be zero. And I received an email from someone. I forget who it was. And even if I remember the name, I wouldn't mention it. But it said, why is future value zero? Well, we're paying something off. So we want to be a good creditor or a good customer. And guys, monthly periods per year and compounds per year are equal to 12. Now, guys, make sure down here at the bottom, payment equal end and not beginning. I pulled a boo-boo a couple years ago when I was teaching this class. I gave an exam on mathematics of finance, and I did all of the questions with begin. Everybody was missing everything. That's not cool. So make sure you'll be off a little bit if you. I've actually be off quite a bit. So anyway, guys, let's get the payments. So the payment is $1,379.34. So now that I've got the information in the calculator, I can start to do some stuff. Okay, so I'm going to run back over here. Well, I'll tell you what I'm going to do. I'm just going to write this down. So the payment is $1,379.34. Now clearly we round to 0.34 because this third digit is 5, which bumps that up for obvious reasons. Now, the next thing I need to do is I need to get my balance after 5 years. So I'm going to get out of this. Once I've got everything set up in TVM Solver, so now I've got some keys that I can work with that information. But I've got to have that information in to be able to make it work. Now, I'm pretty sure this is down at number 9, but I don't do this enough to know for sure. Yeah, okay, so I'm going to check it out. So I want that in my home screen, which is exactly where I need it. And, it's so tempting to just put a 5 there, but you got to remember this has to be in the periods that you have in your PYCY. So we have periods per year as 12. So we have to multiply by that number that we have in PYCY. So we want, because since we're, this whole problem is dealing with months, we need after 60 months. So guys, after 60 months, we have taken the $175,000 and we have reduced it to $130,345.71. All right, now gang, I want to go back over here and show you what I got going on. So this is the dynamics of the problem right here. This is year 0. This is when we start out, and this is after year 5, what we've reduced. So essentially what we can say is we can say that the total we have paid is going to go to 2 parts. Part of it is going to be the interest, and the other part is going to be the amount that the balance is reduced. Well, these are kind of easy to find, aren't they? The total amount paid is just going to be 1379.34 times 60, and the amount of the balance reduced is going to be 175,000 minus 130,345.71. This is going to be our balance started at 175,000, and we see it for using the calculator that we have 130,345.71. So this is going to be the balance, that the balance difference, how much has been reduced over the 5 years. What's left over from the total amount we paid minus what we reduced our balance has to be the interest paid. So let's get out of here and just work some magic. So guys, we're going to have the total amount paid is going to be 1379.34 times 60. So we paid $82,760.40. We have reduced our principal from $175,000 down to $130,345.71. So you might say, well, why didn't all my money go to reduce principal? Well, it would if you weren't paying any interest. So we have to take the difference, 82,760.4 minus 44,654.29, and we get our answer. So 38,000 $106.11 was how much interest we paid in the first 5 years. A lot of money. I've had students before, they're like, Dr. Darver, I really enjoyed your Math 1700 class. I feel like I learned a lot of cool stuff that's going to help me in life, financially. But I don't think I ever want to borrow a house. Look how much money you have to pay in interest to borrow. To borrow money to own a house. Probably it's the best money you can spend. It beats your credit card stuff. It beats that pair of jeans. It beats a car purchase. Purchasing a home is one of the few things that you'll purchase in your life that will actually, or at least most of them, appreciate. All right, number 2 said, how many years will it take for an investment to double if the interest rate is compounded monthly? That's 7.8%. This is a really easy problem if you just use your calculator. If you use TVM Solver, this is a really, really, really easy problem, okay? So first of all, we wanted to double over how many years. Well, I'm just going to put a placeholder there because that's what I'm going to solve for. My interest rate is 7.8. Now this is where things get kind of crazy, okay? With the calculator. What I have to do is I have to put in my present value something. Doesn't even matter. I'm just going to put $1. And then my payment, I don't want to add anything to that. And if I wanted to double, how much will I have if I start out with $1? Well, I have $2. You would think that you put in a positive 2 there, guys. If you do, I'm going to illustrate what would happen if you do this, okay? Just to show you. If you put a 2 there, which is reasonable because you want your dollar to double to $2 under 7.8% at a certain N, and did we say compound monthly? Yeah, we did. So this is going to be 12 and 12. Now, if I go up here to N and solve for N, it's not going to work. If I go green solve like we always do, it's going to give me an error. So let me show you how to take care of that. What you have to do for some wacky reason is if you're solving for something other than PV, PMT, or FV, you have to make one of those negative. Now, if you're paying off a loan, it makes total sense to make your payment negative. If you've got an account that you're taking money out of, it makes sense to make your payment negative, naturally. If you have an investment there and you're adding money to it each month, then it makes sense for your payment to be positive. Well, for one reason or the other, we have to make either the 1 or the 2 a negative, okay? Now, when we go back up to N, we're going to see that if you do it right, you're going to get your answer of 106.98 months. So guys, grab your calculator. 106.98 months, because it said how many years, right? Yeah. So 106.98 months is approximately 8.9 years. Now, a problem like this on my math lab would probably tell you to round to the nearest year. Or maybe not, I don't know. So it would be, you'd probably report your answer as 9 years there. But, you know, I've had students before, let me go back to this. I've had students before say, you know, Doug, Dr. Darber, whatever you call me, how do I know that's months? How do I know that's not years? How do I know, you know, that's not, well, N is always in the term that you have in your PYCY. So if you came up with 106.98 and you had your PY and your CY set as 4, then this would be the number of quarters. If you had this set as 2, then that would be semi-annually, twice a year, so you'd have to divide that by 2 to get your number of years. So N is always in the periods and the compounds that you've set your calculator to down here. So that's just something you got to remember. All right. Like, how you know that? Well, I learned it. I just decided to sit down one day and learn it. John and Teresa plan to buy a house for $500,000 and cannot decide whether to amortize their loan by making equal monthly payments or equal quarterly payments. You know, back in the day when you had to write out a check, and some people still do that, but I prefer not to. I prefer to have it just automatically withdrawn from my account. But back in the day when we used to have to write out checks every month, and again, some people still do that. It's kind of a pain. Sometimes it's easier to just write a check out every 3 months, you know. So I just want you to see really more the dynamic here of how much money you actually do you do save. So let's make this happen. So again, there are fancy schmancy formulas out there that do this kind of work for us, but I'm not teaching you that. So the first thing, we want to buy a big old fancy house for $100,000, and we can't decide whether we make monthly payments over 30 years. Well, let's just figure out what the monthly payments will be. Do I have to have 30 times 12? Either rate, the interest rate is 5.75. Either rate, the present value is $500,000. So they bought him a big old fancy smancy house. That's $50,000. We want to be a good creditor and get our balance down to zero at the end. And we're doing over monthly payments, so PYCY would be 12. Now, if I go back and get my payment on this house would be $29.17. So this is monthly. Now all I'm doing is so $29.17.86 per month. So you're going to need a pretty good job if you can afford a payment of $29.17.86 per month. Now, next thing I want to do is I want to change this into quarters. So N is going to be 4 times the 30. And I've got to come down here and change my PYCY to 4 instead of 12. So I'll go up here and get my payment. So we're going to expect a payment, somewhere around $1,200 every quarter, multiplying that by 3. Multiplying that by 3, I multiplied by before. So the quarterly is $87.69.25. Now that still may be a wise move. We're going to find out that you pay less by monthly payments, but it still may be a wise move to do quarterly, even if you pay it more. But that would be depending on your cash flow. So, guys, the first thing I want to do is I want to find out how much I pay quarterly. So I'm going to take my 80. I'm going to put this in parentheses because I want to subtract the monthly. So $87.69 times 4 times 30. And I'm going to subtract how much I would pay monthly, which is $29.17.86 times 30 times 12. So the difference is just $1,850.40 over 30 years. So if you divide that by 30, it turns out it's only about $60 a year. But it's $60 a year. That's whatever you want to do. There's no way I can tell you. So, guys, the answer to number 3 would be $1,850.40. And a lot of students, sometimes they'll give me an answer like that, and they'll give me like $2,200, and they're like, "Well, Dr. Darber only missed that by $400." But you think about it, you shouldn't miss it at all. We know how we're going to round. Let's see. Did I do that right? I actually didn't, did I? Gosh, I don't know what I was thinking about here. I should have taken 87.69.25 times 4. I got sloppy here, boys and girls. Minus, it's not going to make much difference, 29.17.86 times 12 times 30. So I got a little bit sloppy there. That's not cool. So the correct answer should be 1880.40. So I'm going to... Because you might say, well, it's only $30. I know, it's only $30. It's only $1 a month. But there's no reason not to do it right. There's no reason to get sloppy like that. That was a very bad teacher of me. Okay. All right, so $1,880.40. All right, gang. The Malones plan to purchase a house for $250,000, make monthly payments for 25 years, 4.25. How much money will they save in interest if they are able to add $100 to each payment? This is more sophisticated. This is more, and this is something we all run into. Should we make more add an additional $100 or whatever per month. And people always tell you what saves you a lot of money. Well, what does that mean? It saves you a lot of money. $300, $3,000, $30,000. Well, after this illustration right here, in about probably 10 minutes after we finish it, because this was a little bit more sophisticated, it's a little tougher, you're going to know how to do this. You're going to know how to figure out whether that is indeed your advantage to do that. All right, first thing, we need to get into our calculator and put the information in. So the Malones are doing a $250,000 house, 25 years. Let's do 25 times 12. The interest rate is 4.25, so that's reasonable. They're buying a $250,000 house. Payment, I'll put as 0. We'll come back and get it. You guys don't get sloppy at the bottom. If you wake up tomorrow and you want to get all these problems wrong, then ignore this PYCY down here. You're going to get it wrong a lot. So let's calculate the payment. Per se is $1,354.35. So I'm going to do some split screen here because I want some stuff going on where you can see everything. All right. All right. I wonder if I can move that. Nope. All right, well, you can see it over here. All right, gang, so what we have is we have a payment equals 1354.35. Now, essentially, at this, we're going to pay the bank what do we say here, 25 years? That amount of money. That's 25 years, right? Yeah. So isn't that comforting? On a $250,000 house at a pretty good interest rate, you're going to pay $406,000. Wow. Not only that, you're going to have a car payment, maybe 2. You're going to try to save for retirement. You're going to try to save for education, for your kids. You're going to try to survive with your kids through gymnastics and all those crazy things. And you're probably going to have student loan debt and so on. So, guys, everybody's depressed now. Enjoy it. It's life. It's good stuff. All right, gang. Now we got to figure out what would happen if we increased our payment by $100. Now, you got to remember in TVM Solver that we have a payment here of minus $1,354.35. Guys, you got to start that with this negative right here. So I'm going to type over that. I'm going to go minus 13. You choose the wrong negative, you're going to get an error, and you're going to think, oh, I don't know what I'm doing. I'm going to lose my mind. Well, you got sloppy. Don't get sloppy, okay? You got to use this negative right down here that I used. If you use this one up here, you're going to get it wrong. It's going to give you an error on your calculator. So you make the decision what you want to happen. So 1354.35. But I want to add another $100 to that. And it's kind of weird that you've got to subtract here because you're increasing the value that's coming away from the $250,000 each month. So you subtract another 100 because it's a payment. It's coming away from the $250,000. Now just hit enter and you'll see that you've added $100 to your 1454, okay, 0.35. But now we want to go up here and see how long, or at least how much quicker, we pay off our loan by adding the extra $100. So if I go green solve, I can see that I get this paid off instead of 300 months. I get it paid off in 265.472 months. So I'm going to write that down. So instead of paying 1354.35, I paid 1454.35. But this 12 times 25, that was my 300. But so I just need to put the 265 that I get from my calculator. Let me get that out of the way. 472. And I can go out as far as I want on this. The further I go out, the better answer I get. But typically, if you go out 3 or 4 points, 3 or 4 places, it works out pretty nicely. So we can see that if we paid the 1454.35 times the 265.472, that we're just going to pay the bank $386,089.20. So we pay the bank less, don't we? Pay the bank less because we're chipping away by putting that extra $100. We're chipping away at our principal more quickly. So guys, I can take the 406,305, which I would have paid the other way, minus the answer. And I see that I would save over $20,000, just slightly over $20,000. Yeah, that's what smart people do. That's, it's only over 265 months. So let's see how long it would. So if over 265 months. So instead of paying this off in 25 years, now you would pay it off in about 22 years. So you'd pay it off about 3 years earlier, and you'd save yourself about $20,000. That'd be a good $20,000 to put on a college education for your kids. Be a good $20,000 to take a trip. So anyway, that's probably what I would do. I love to travel. So 20,215. I really don't like to travel. I hate the travel part. I really get fed up with the airlines and stuff like that. But I love seeing new stuff. All right, gang. Let's get out of this. So the final problem on this handout, John and Amy are. Now this is a depressing problem. I'll just go ahead and tell you, because what I'm going to do is I'm going to do everything right, and we're going to find out that it doesn't really work as well as we would think. All right, so John and Amy are planning to save for retirement and intend to do so by making a lump sum investment of $25,000 into a savings account that earns 3.5% interest compounded monthly. So that tells me PYCY has to be 12. In addition, they will add $350 a month to the lump sum investment for the next 30 years. So this is a very, very mature approach, I think, in trying to trying to save for the future. Okay, so what will be the value of their investment after 30 years, including the lump sum investment and each additional monthly contributions? Well, guys, without your calculator, this is a very hard problem. With your calculator, this is a very, very easy problem. So I always like to start, when I start a new problem, clear out, just make sure I don't get any calculator issues. So it looks like after the the lump sum investment of $25,000, They're going to make monthly payments for 30 years. So I'm going to have 360 periods that I have to consider. 3.5. And the lump sum investment, I just sometimes laugh at the weirdest things, of $25,000. So they're going to put an extra 350. Now the question here, should that be negative or positive? Well, it should be positive because what we're solving for is future value. One of these three has to be negative, and when the calculator solves for FV, it's going to give us a negative number, although we interpret that as a positive number. So we're adding to an account, not taking away from a loan. So this is going to be 350 naturally, positive. Okay, we're making the investment additions monthly, so PYCY have to be 12. So guys, you'll see that Amy and John turned out with a significant amount of money. So the value of their investment after 30 years, including all of it, is $293,000, 726.64. So they end up with almost $300,000 in their savings to prepare for retirement. Now, the next question we get on the handout, so I just put that answer right there, is $293,726.64. Now, the next thing is how much interest is learned. Well, this is the same thing we talked about earlier. You take the total amount you have, take away the contributions that you made, and the rest of that has to be interest. So if we can take this amount of money and subtract the contributions, then the next bit of that has to be the interest that was earned. Well, guys, that's going to be really, really, really easy if you just think about it. So we can take the 293,726.64, and let's subtract out what we've put into that. First thing we did is a lump sum of 25,000. And then we subtracted, and we got to put this in parentheses because it's all multiplied together. We did 350 for each month for 30 years. Right? So the interest earned on that account was pretty good. It was 142,000. 726.64. Okay, that's a tough problem if you don't have TVM Solver. It really is, because each time, like for example, you start out with 25,000, and then you add the $350. Then you have to calculate your interest, and then you start that for the next month, that amount, and you add 350 to that, and you get a new ending balance. You have to multiply that by 0.035 divided by 12. And then that becomes your new balance for the third period. Then you add 350 to it. You get your balance. You have to multiply it by 0.035 times 12, or divided by 12, because your interest, again, is per month, not for the total year. All right, guys, after 30 years, this is where it gets depressing. After 30 years, John and Amy decide to withdraw $2,000 per month. If the account continues to earn 3.5% compounded monthly, how many months will it take to eliminate their savings? Well, this is all about just using a little bit of common sense, I think, on your TVM solver. So we want to know how many months, so I'm going to put a 0 there. I continue to earn the 3.5, but now I'm starting out with the 293,726.64, starting a new term, if you will. I want to pull out $2,000 a month. That's not a crazy, enormous amount. And I want to see how long it takes to exhaust the savings account. Okay? Now, remember again, this is in months. So I got the negative there for obvious reasons. Again, PV, PMT, FV, one of those three has to be negative. So it's a natural place to make that one to be negative. So when I go up and solve for n, I see that it's going to take 192 months to exhaust my savings. 192 months. So let's get out of that and see what that is. 192 months is 16 years. These people worked hard for 30 years, saving $350 a month after a lump sum of $25,000, and they would exhaust their savings in 16 years. So, you know, you see people sometime, you're thinking, you know, should I retire at, at 60 years old, or should I retire at 55, or should I retire at, at 72? You know, it's always, a big thing about what year will you retire. And some of your parents or grandparents may be going through that right now. Well, let's think about it. Let's say someone wants to retire at 60 years and has been very responsible and did this, put down $30 or $25,000, and for 30 years put $350 a month away. Well, if this exhausts if they exhaust their savings in 16 years, by the time they're 76, they're going to be broke. So it's kind of depressing. In 76, with our medical advancements today, and considering that if you look at this, and let's say this person is really thinking about doing this, and right now, and they think, well, that's 30 years later, and then here's 16 years later, so they're talking a span of 46 years. Just reflect on the changes that we have had in our society over the last 46 years. Think about computers. Think about medical advancements. It used to be, cancer is still not something you want to hear, but it used to be, it was a death sentence. There are certain types of cancer that we're actually having some luck curing and maintaining or increasing people's increasing their life. So who knows what's going to happen in the next 30, 40, 50 years. But long story short, it's very, very likely that these people will live longer than age 76. So anyway, probably one of the reasons that our government is looking at increasing the ages from 62 and 65 to maybe 65 and 68, when people can start drawing start drawing Social Security. So, gang, that's all I got. Have a good one.